Hello, welcome to another intermediate algebra broadcast. We're going to take a look at rational equations today. So quiz 6 is about rational equations, and you have a few equations, all with variables in the denominator, that you need to solve. Now this is the same kind of stuff that you're going to see on your final exam, which is part 5 of the exit exam. And so I grabbed a few of these problems to take a look at with you. So let's start here. Nice thing about equations over expressions is we can eliminate the denominator because we have two sides of an equation to work with. So the first step in a situation like this is to identify what is the lowest common denominator. So the first denominator says it needs an x in it. The second denominator says it needs more than one x. It needs two of them. So x squared is the lowest common denominator. So what we'll do is we'll take this equation and multiply both sides by x squared. And that means each piece is going to be multiplied by x squared. So I'll have x squared times 1 minus x squared times 5 over x equals x squared times negative 4 over x squared. And remember, multiplication is the only time that you can cancel ahead of time. So I can view this as x squared over 1. It's multiplication of two fractions. X goes into x squared x times. Over here, the x squareds cancel completely. And so it looks like we've got x squared times 1, which is x squared, minus x times 5, or 5x, equals negative 4. So the power of the LCD is that it eliminates all denominators and we get a much easier equation to work with. So here, since we have a quadratic, I would attempt to get 0 on one side. So I'll add 4 to both sides. So that's going to give me x squared minus 5x plus 4 equals 0. From here, I can pray at factors. I could complete the square or use the quadratic formula. Looking at this, I believe it factors. Let's try. I believe x is x, or x squared is x times x, and 4 is 1 times 4. And since that's a negative 5 and a positive 4, these must both be negative. Negative 1 times negative 4 is positive 4. Negative 1 plus negative 4 is negative 5. So, yep, it factored. Breaking this down into two parts based on the 0 product rule, I have 0 and a product. Either x minus 1 equals 0. So x equals 1 looks like one answer. Or x minus 4 equals 0. And x equals 4 is another answer. Unfortunately, I do not know that's true, and I have to check. I think I have answers, but I don't know. So as far as the check goes, plug those numbers in and see what happens. So check first for x equals 1. That's going to give me 1 minus 5 over 1 squared. Oh, no, square's not there. Other side. Equals negative 4 over 1 squared. And then clean up one side separate from the other. So 5 over 1 is 5. 1 minus 5 is negative 4. Negative 4 over 1 is negative 4. Check. Now the other one. Let's check to see what happens when x is 4. That's going to give me 1 minus 5 over 4. And I think maybe that equals negative 4 over 4 squared. And then we clean up one side separate from the other. So 1 minus 5 fourths, well, that would be 4 fourths minus 5 fourths, which is negative 1 fourth. On this side, that's going to give me negative 4 over 16, which reduces to negative 1 fourth. And yep, both of them do check. So I'm going to recircle. I have two answers here. You never know till you check. Could be one of them works, could be none of them work. Could be both of them works. You have to check on these problems, otherwise you will not get it correct. Let's try another. All right, here we got to identify the LCD. First one says it needs an x. Second one says it needs a 3 times x. So 3 times x it is for the LCD. Then we have to multiply each side by 3x. And on the right side, that means the 3x has to be distributed through to each term. So that's going to give me 3x times 6 over x equals 3x times negative 8 over 3x plus 3x times 8. And then clean up. The x's divide out there. 3x divides out there, and nothing divides out there. So what's left is 3 times 6, or 18, equals, all that's left is the negative 8 there. And then 3x times 8 would be 24x. This is nice, no squares, so to solve for x, I need to move that negative 8 over. So I would add 8 to both sides. So 18 plus 8 is what? 26 equals 24x. And then divide by 24. I'm going to get x is 26 over 24. And I can reduce that. Let's see, they're both even. So 2 goes into 26, 13. 2 goes into 24, 12. So it looks like 13 twelfths is my answer. I need to check to be sure. So we're going to come over here and check to see if it's true that x does equal 13 twelfths. Sometimes checking is just as much work as solving, but you got to do it. 6 over 13 twelfths. And that's supposed to equal negative 8 over 3 times 13 twelfths plus 8. All right, so cleaning up the left side, if you divide by a fraction, that's the same thing as multiplying by the reciprocal. 12 thirteenths, and nothing cancels. 6 times 12 is 72 over 13. Let's hope the other side gives me the same thing. Let's see, 3 over 1 times 13 over 12. 3 goes into 3 once and 12 4 times. So it looks like we have negative 8 over 13 fourths. And plus 8, multiplied by the reciprocal, negative 8 times 4 over 13. Gives me 8 times 4 is 32, so negative 32 over 13. If I view this over here as 8 over 1, common denominator would be 13. Let's see, 8 times 13 would be 80, and 24, which is 104. And negative 32 plus 104 would be 104 minus 32, which is, yep, that checks, 72 thirteenths. I do indeed have the right answer here. Okay, got to check to know, otherwise you don't know. Next, 2 strategies we could apply here. One would be to apply the LCD method, in which case the first one says it needs an s plus 11 as a factor, and the second one says it needs an s plus 8 as the factor. So then we'll have to take that times each side. So that's going to give me s plus 11 times s plus 8. Multiply that by 2 over s plus 11. On the other side, same idea. We'll have s plus 11 times s plus 8 times 3 over s plus 8. And the s plus 11s cancel on one side, leaving me 2 times s plus 8. So that's 2s plus 16. On the other side, the s plus 8s cancel, leaving me 3 times s plus 11. So that would be 3s plus 33. So to solve this, I think I will subtract the 2s over, because then that gives me just a 1s or an s. And then I'll, let's see, consolidate, bring the 33 over to the other side. Oops, minus 33. And we get s equals negative 17 is what we think the answer is. And so now we have to check. So we're going to check, oops, see if s equals negative 17. So that would be 2 over negative 17 plus 11 is supposed to equal 3 over negative 17 plus 8. All right, negative 17 plus 11 would be a negative 6. So I get 2 over negative 6, which is negative 1/3. So 3, believe it or not, better. On the other side, I've got 3 over, subtracting 17 from 8 is going to give me a negative 9. And 3 goes to 9 3 times. So yeah, there's negative 1/3 again. So this does check. Negative 17 is a solution. We're on a roll. All right, I mentioned there's another way to do that. So let's take a quick look at that. Since it says, and we can tell by looking that it's a proportion, we could apply the techniques of a proportion, which is to find the cross product. So take the s plus 8 times 2, and that's supposed to equal the 3 times s plus 11, which you should notice is what we ended up with in this second step over here. So if you happen to notice proportion, cross product can find it a little quicker. If it's not a proportion, you can't apply the cross product. So you can either stick with the same method all the time with the LCD, or if it's a proportion, you have this method here. So I think you can continue that from there. Let's move on to another. All right, this one's a bit of work. X minus 1 is factored, x plus 3 is factored, but x squared plus 2x minus 3 is not. So I'm going to guess that that factors as x squared is x times x, 3 is 1 times 3, and to get a positive 2 in the middle, it's going to be a plus 3 and a minus 1. Double check. Negative 1 times positive 3 is negative 3. Negative 1 plus 3 is positive 2. Yep, that is correct. So this is my denominator there. And that's a nice thing because that x minus 1 and the x plus 3 match. So that is the LCD. X minus 1 times x plus 3. So now we have to multiply each piece by that denominator, that LCD, and see what cancels. So x minus 1 times x plus 3 times the first fraction, x plus 1 over x minus 1 equals x minus 1 times x plus 3 times the next fraction, negative 2 over x plus 3, and then plus, same idea, x minus 1 times x plus 3 times the last part, 8 over And I'm going to write it in factored form, x minus 1 times x plus 3. It's that last denominator. And then see what cancels. So in this last one, the whole denominator cancels with the LCD that we multiplied by. Second one, just the x plus 3 cancels. And the first one, just the x minus 1 cancels. And I'll put that in parentheses to be safe. So cleaning up what's left, I have to multiply x plus 3 times x plus 1. And that's going to give me x squared plus x plus 3x plus 3 equals x minus 1 times negative 2. That would be a negative 2x. Negative times a negative is plus 2. And the last part, I have just a plus 8. Cleaning this up a bit, we get x squared plus 4x plus 3 equals negative 2x plus 10. Bringing everything to one side, because there's a square, I would want to add this 2x over to its like term here. And I would like to add that 10. No, I wouldn't. I would like to subtract that 10 over to its like term, the 3. Consolidating, what do we have? We have x squared plus 6x minus 7 equals, 0. Hoping to use the zero product rule if this factors. Ooh, looks like it might. Let's check. X squared is x times x. 7 is 1 times 7. And this would have to be a positive 7 and a minus 1. Minus 1 plus 7 is 6. Minus 1 times 7 is negative 7. Check. So that tells me that x plus 1, or x minus 1 is 0. So x equals positive 1. One possible answer. Or x plus 7 equals 0. So x equals negative 7 is another answer. Is this true? I do not know yet. I got to plug them in and see. So let's check on a new page. Always go back to the original, not any altered version. We're going to check first x equals 1. So your work is not done until you check. Plugging that in everywhere I see an x, I would get 1 plus 1 over 1 minus 1. Oh, darn, look at that. I'm done checking this one. That is 2 over 0, which is undefined. X cannot be 1. Does that mean the other one has to work? The answer is no, it does not mean that. I got to check that one too. All right, x cannot be 1. Problem with the denominator. So just note, x couldn't be 1 and x couldn't be negative 3. I have another guess of negative 7. Let's check it out. All right, and how about x equals negative 7? Got to plug it in and see. Negative 7 plus 1 over negative 7 minus 1. Does that really equal negative 2 over negative 7 plus 3 plus 8 over negative 7 squared, parentheses are necessary, 2 times negative 7 minus 3. Let's see. Left side, that looks easier. Negative 7 plus 1 is negative 6. Negative 7 minus 1 is negative 8. Negative over negative is a positive. And 2 goes into the top and bottom, 3/4. Does the other side equal 3/4? Let's hope. Let's see. Negative 2 over negative 4. That's 1/2. Plus 8 over 7 squared is 49. Minus 14. Minus 3. Let's see. 49 minus 14 is going to be what? 35? 35 minus 3 is 32. And 8 goes into 32, so that's 1/2 plus 1/4. Yep, 1/2 plus 1/4 is definitely 3/4. Check. We have one single solution here. Again, you can have one, none, two, or more. It all depends. We checked. We conquered. Nice job. All right. Have fun practicing this stuff. Take care and do good math. Bye-bye. If I can exit. There we go.